morning, guys. Obviously, you can see that I am not here today. Unfortunately, my grandmother passed away over Thanksgiving, and we are having her burial today. So I hope you won't mind a video for our lesson today. And I'll just go through like usual. Hopefully, you guys got your notes from the folder at the front of the room. And I will check your homework in when I return on Tuesday. So then on Tuesday, you should be able to show me your homework from over break, as well as the homework that will be assigned to you today. All right, so here we go. Today we're starting lesson 10.3. This is day 1 on this lesson. You can see we're going to be talking about polygons, perimeter, and tessellations. This is the last lesson that we're going to do before we take a quiz. And as of now, your quiz is going to be at the end of this week, okay, on Friday. So here we go, vocabulary. A polygon. Polygon is just a fancy word for a shape. Here is the formal definition. Please notice that it says 3 or more sides. Obviously, you can't have a shape with any less than 3 sides. Notice in the next vocabulary word, the word regular is highlighted. That is important. A regular polygon is a polygon whose angles are all congruent and whose sides are the same length. Okay, so that's what it means to be a regular polygon. Hopefully, you're not a senior in high school and don't know what a triangle is. A triangle has 3 sides, and it is named by the types of angles and side length. And we will go through those different types now. First, we have a scalene triangle. And this means there are no congruent sides. Okay. Next, we have an isosceles triangle. And this has 2 congruent sides. And finally, we have an equilateral triangle. An equilateral has 3 congruent sides. Okay, so obviously if it's an equilateral triangle, that means it's a regular polygon, because by definition, regular means all the sides are the same. Okay. Now in that definition of triangle, I said by name, by types of angles and side length. The types I've given you here in green are the types by side length. We have already talked about angles. Okay, you know that an obtuse angle is bigger than 90 degrees. So if a triangle has an angle that is bigger than 90 degrees, it's called an obtuse triangle. If there is a triangle that has all angles less than 90 degrees, then it's called an acute triangle. Next, we have a quadrilateral. And a quadrilateral simply has 4 sides. Hopefully you know that prefix of quad means 4. And we have lots of types of quadrilaterals. Okay. The first type is a parallelogram. And I think what I'm going to do, guys, is I'm going to go through and write all these down and then go back and explain them. So you can go ahead and write, and then I'll go back and talk about each one. All right, so there are your stipulations for a parallelogram. And parallelograms look like this. Okay, so we have opposite sides that are parallel. So this would be parallel to this, and this would be parallel to this. We have opposite sides that are congruent. So this guy would be congruent to this guy, and this guy would be congruent to this guy. And finally, we have opposite angles congruent. So this angle would be congruent to this one, and that one would be congruent to that one. Next, we have a rhombus. Now, a rhombus is a type of parallelogram. So all the things that a parallelogram has, a rhombus also has, except for a rhombus has all sides congruent. And then obviously I didn't put in my arrows there to mean parallel, but you know because that's a parallelogram that those opposite sides have to be parallel. Next we have a rectangle. A rectangle is also a parallelogram. It is a parallelogram, though, that has 4 right angles. And I'm sure you know what a rectangle looks like. Okay, and again, it's a parallelogram, so opposite sides are parallel. Next, we have a special type of rectangle, which would be a square. Okay, so a square is a parallelogram. It is a rhombus, and it is a rectangle. Okay, but, I shouldn't say but, if all of those 3 things are true, then you know that a square looks like this. And last but not least here, hopefully you got just a little bit more room, we have a trapezoid. A trapezoid is kind of in a category by itself because it only has 1 pair of parallel sides. And a trapezoid looks like that. Oops. I'll put the wrong markings in there, sorry about that. Those are parallel. They are not congruent, they are parallel. If it's an isosceles trapezoid, then these sides over here would be congruent. Okay, but that's only if it's isosceles. All right, a few different shapes. We have a pentagon, a hexagon, a heptagon, and an octagon. And remember, guys, if they are regular, that means all of their sides are congruent. So let's take a look. Identify the polygon by its number of sides. Notice all they're telling you is the number of sides. They're not telling you about angles. They're not telling you about parallel sides, just the number of sides. There are 4 sides here. So it's a quadrilateral. This one has 5 sides. So it's a pentagon. Okay, let's come down here to the bottom. Use the quadrilateral, so they're telling you they all have 4 sides, to the right to solve the following exercise, which have opposite sides that are parallel. Name them. A is a square. Those have opposite parallel sides. B is a rhombus. Those also have opposite parallel sides. Notice it's a rhombus because all those sides are congruent. D is a rectangle because that has opposite sides parallel, and you notice that the 4 right angles are in there. Notice I skipped over C, folks. C is a trapezoid because letter C does not have all of the opposite sides parallel, just one set. And then finally we have letter E, that is a parallelogram. Okay, next it says, which have right angles? Name them. Okay, well, we've kind of already done this. A is a square, and D is a rectangle. Which of them could not be classified as a parallelogram? Name it. Well, the only one up there that is not a parallelogram, meaning both sets of opposite sides are parallel, is letter C, and that is a trapezoid. All right, we are all set with side 1 here. Let's go ahead and go back to side 2. Remember, you can pause this and replay as much as you need to get all your notes today. Find the perimeter. Be sure to label its units. Okay, well, perimeter, again, you're not a senior in high school without knowing what perimeter is. A perimeter is the outside. Like if you were fencing around something or you're putting a border around something. So really easy here. We're just going to add everything up. Number 1, that rectangle has a perimeter of 30 centimeters. Number 2, they tell you it's a rectangle, meaning the opposite sides have to be congruent. So over here we definitely have 6, and up here we have 8, which makes that a perimeter of 28. Notice I'm labeling my units here. Number 3 is a square, they tell you, so that means you can fill in the rest of these sides. And you get a perimeter of 1,000 inches. All right, no surprises in number 4. This is an irregular shape, but they tell you all of the sides. So if you add them all up, you will get 84 yards. Now in number 5, we have another irregular shape, but you kind of have to do some math here to figure out the missing sides. Well, if I want the vertical side over here, that is made up of this vertical side and this vertical side, so that will be 7 feet. And if I want this horizontal side down here, that is made up of this horizontal side and this horizontal side, which would be 9 feet. And now we have all of the sides, so we can find our perimeter to be 32 feet. Easy enough. Okay, the last thing I want to finish up with today are the interior angles of a polygon. I've got a pretty lengthy definition here for you, so I'll go ahead and write it, and then you can copy it down. Alright, so here's your definition. The interior angles basically means the angles on the inside of a polygon. Okay, if it's regular, that means they are all congruent. So I'll just give you an example here. If I draw, how about a pentagon? The interior angles are the angles on the inside of that polygon. So it has 5 sides, therefore it has 5 interior angles. And if I tell you that all of the sides are the same, that means that all of those angles will also be the same. Okay, so we have a formula here to find the sum of all of the angles inside a polygon with n sides. So this will tell you how much all of those angles inside of your shape add up to. So if I have a 5-sided polygon, I'm going to use n is 5, and I'm going to plug it in to this formula right here. So if n is 5, that would be 3 times 180, which means 5-sided is a pentagon, inside a pentagon, all of the angles add up to 540. If we talk about a quadrilateral, my n is now 4. So that would make my formula 2 times 180. So inside of a quadrilateral, all of the angles have to add up to 360. And finally, a decagon. Deca means 10, folks, so my n is 10. That would be 8 times 180, which gives me all of the angles adding up to 1440. Okay, so that is your notes for today. Your homework is, of course, found out of your book. And again, this homework, as well as the homework that you had over break, will be due tomorrow, and I will check both of those in. I hope you understood everything okay. Remember, you are able to work together, and hopefully you can help Charisse, because she is in this class for the first day today. So help her out, show her kind of the routine that we normally follow, and I will see you guys tomorrow.